This is our solubility lab as walked through by me and a little bit of voiceover by me as well. So we'll start with part one. This is just miscibility, so liquid and liquid. Primary goal, strongest force, and how that applies to solubility. So first we've got our lab set up. We got a glove up, so we got to put on our gloves and get ready to go to make sure we are protected. We'll see a close-up of each of the test tubes. Note this one has a little bit of water in it. That's okay because we're just going to mix it with water anyway. So we're going to start with absolute ethanol and then water. That absolute just means it's super concentrated, that it's only ethanol. That's the only reason behind that name. I had some dexterity issues on the back end, so just to give you an idea, you'll see the test tube, hopefully a nice zoom in or refocus on the test tube with our first liquid on it, and then you'll see the second liquid added in over the top. Hopefully the sequencing of the words and the language all aligns, but it might not. But you want to make careful observations both initially and a little bit later, because perhaps your observation will change depending on what you see with other results. More things to observe as you're going through and doing this is notice what's happening with the reagent bottles as well, because I am changing the technique with how I'm using them. Consider those different techniques and ask yourself which one might be better or worse than others. Here what we're going to use is diethyl ether, which is exceptionally volatile and it can cause problems with our glass pipettes. So what we want to do is stick our pipette into our said liquid and suck it up and spit it out a couple times. If we don't do that, you'll see this subtle kind of spitting that it does, and it constantly drips out. Sometimes it's worse than others. But if you suck it up and spit it out a couple times, it builds up enough back pressure that it doesn't spit out anymore. Note the capping here, and then we'll see the zoom in here in just a second. And here again, we might see those two layers. We want to ensure they mix, just like we did with the ethanol. We can do a finger flick at the bottom, and that will help agitate those two layers to get them evenly mixed, if they will. This next one is doing the same kind of addition that we ran last time, water, then an organic, so aqueous, then an organic phase. So same sequencing of the materials, what kind of result do we get? Note there's a little bit of drippage that happened from our pipette already. That mixture was a little bit weird and different this time than the last one. So here what we're doing is adding a little bit more water. Let's see what the water helps us to see. That meant the top layer was the aqueous and the bottom layer was the organic. And here we start yet another way that we could dispense of liquids. In this case, what we're going to do is pour out hexanes into a beaker because we're going to use a significant amount of it. So what we'll do is pour out roughly how much we need. We don't have to get super precise, but we don't want to waste a bunch either. So we'll pour in how much we want, cap our container, and then we can cover it to make sure we reduce evaporation. This way we don't have to worry about constantly going in and out of the stock bottle. And just like the last one, we'll do water first before we add the hexanes. The hexanes is again going to be added via a glass pipette. So we want to make sure that we get that rubber pipette bulb on, keep the tip always aimed down so the liquid doesn't rise up into the pipette or into the pipette bulb. And we can suck up our liquid, do a couple spits just to ensure we don't get any back spitting, and then careful hand gestures here so that we can align it. We've done our mixing, and again what we'll do is go ahead and add a little bit more water. So again, we're using the water to help us identify those layers. Water is cheaper than the organic substance and less hazardous, so it's usually the better substance to add. That helps us to decide which layer was which within our individual reaction. Hey dude, I think you forgot something. In our last test, we're going to do our hexanes, which takes a little bit more effort because of the extra equipment there, and methylene chloride, and we'll see that pop up here in a second, describing what we're mixing. Same deal, we'll do the flicks, make sure they mix, make our observation, and then we're done. I also forgot to put the pipette back. That was a smart thing. Good thing I edited that quality out. So get your last observation in of this last mixture and consider potentially going back and changing or rewatching any of the other mixtures before we move on to part 2 now. Part 1 looked at the strongest force. Part 2, what we want to do is dig a little bit deeper into that strongest force and decide, are there other mitigating factors? So here what we're going to do is prepare our 3 samples with water, because if we can prepare them in bulk, it makes it a little bit easier to deal with. And since water's volatility is relatively low, we don't need to stress about it. The next part is we're going to mix it with a variety of alcohols. The ones we're going to test are going to be methanol, butanol, and octanol. Technically, we already tested ethanol, so you should go back and add that to your list. In this case, you'll notice there's some parafilm wrapped around that. That helps to keep the chemicals inside the container, prevents kind of slow evaporation of those substances. Again, notice the pipette, keep the tip down as much as possible. See how I'm holding it to keep that tip aimed down. And we'll go ahead and start our mixing process. And again, this was methanol and water. Notice any issues in the background? So again, we've done our addition. So make that observation. I just realized you might be able to hear my dryer in the background. So I'm going to see if I can fix that in a second. Interesting. Does your observation potentially change after mixing? It's a good thing to note. It's been a little too quiet for too long, so we'll go ahead and point this out because someone invariably does note We have the stock bottle here, and what we're about to do is dip directly out of the stock bottle. This is not a good proper protocol. We should be pouring it into a secondary container and then dispense. Why are we doing it this way? That would be a good question. Another opportunity to just kind of talk for a second here. You'll notice that our methanol and the one we're not testing explicitly here because we did it earlier with ethanol are just written as the name. But when we look at butanol, it said 1-butanol. And if you remember back and think about it when we watch the octanol part, the butanol and octanol both have a 1 in front. That's the nomenclature system to refer to the exact location in the carbon chain where the alcohol functional group is located, that OH. For methanol and ethanol, we don't have to specify the 1, and in fact, some would argue we should not specify the 1 because it is redundant information. It has to be at position 1 for methanol because there's no other carbon. For ethanol, it's just 2 carbons, so we want to always assign the lowest number. So it doesn't matter where the OH necessarily appears, nomenclature-wise, it will always appear at position 1. Starting with propanol, now we have to get specific with the nomenclature on where it's falling. This dead space of audio is bothering me somewhat, so again we'll call out, keep our pipette tip aimed down. We will also notice that you see that little pinky missing. That's an artifact again because I need to be able to touch the cell phone to stop the recording. Ideally we have our gloves fully protecting our hands and we don't encounter that potential space for contamination to seep through. Note that we covered all of our containers before going to our actual reaction. And again, we can make our observations. Again, look to see what it looks like at first, then make an observation after you do the mixing, recognizing that it could potentially change. The nice classic example, a snake bite if you're over 21. Really now we're about to clean up. So note that we tried to make sure the lid was on nice and secure. It is my recommendation that you have a waste beaker handy so that you can dump all of your small test tubes or other reactions into a single container and then dispose of the waste from that beaker into the waste hood. Otherwise, you end up spending a lot of time in the waste hood, and that's just annoying. Okay? Once it's all disposed of, or you happen to notice that it doesn't all come out, that's where you could go through and do a small being the operative word, water rinse. Okay? We're not filling up the test tube. We're doing a small splash of water, milliliter at 2 at most, and we dump it out. Whatever still sticks behind can be washed in the sink. The sinks do trap some waste, they just don't trap it all. So we have to get the majority out before we start our cleaning. When we move to the sinks to do our cleaning, with test tubes, you'll notice I'll take a fistful of test tubes, fill them up with a little bit of soap. I like adding a little bit of water to help me get a little more froth, and then clean each and every single one of them with a scrub brush, making sure that your glassware is constantly touched by soap so that you can remove those nasty chemicals. Once you've done the soaping process, then you can move on to rinsing. All we're trying to do is remove the bulk of that soap and get it all out. And really, not even the bulk, all of the soap. So these would now be kind of officially clean. However, tap water is dirty inherently. So what do we want to do? We want to make sure we give our glassware a quick rinse with the deionized water. Again, generally I like 2 rinses just to make sure we've reduced and removed the majority of the ions that came from our tap water. We can now set them out to dry. Depending on if we need to use them immediately, you may decide to actually dry them physically with a paper towel. If it's the end of the day, don't spend your time drying with a paper towel. One of the advantages of living in the desert is it will dry by the next class period. So use that to your advantage. It does help to put everything away. Note that we're putting it open end down so the water can drain out better. If we do it the other direction, what will end up happening is the water stays trapped inside the container and it doesn't dry out very quickly. If you need the glassware right away and it needs to be dry, a very common method to kind of remove the remnants of water is to use a secondary organic solvent to remove it. Acetone is a great option. In this case, I didn't have any acetone, so what I went through and did is used a little bit of ethanol first, which removed the vast majority of the water. The added bonus for our ethanol is that its boiling point is a little bit lower than that of water, so it should evaporate and quote unquote dry quicker. The next thing that I went through and did, because I wanted it really bone dry, was rinsed it with hexanes. Hexanes has an even lower boiling point than the ethanol, and I wouldn't do it right away because hexanes won't get rid of the water. Right? Because hexanes and ethanol are soluble, hint, hint, that sets up that test tube for part 3, where we're now going to kind of apply our knowledge out to a bunch of vitamins to see if we can't predict something about their structure based on their solubility in a variety of solvents. This is probably going to be another long stretch of no audio because I'm not sure what else to add. But we're going to test each of these individual samples. The lab asked for 30 milligrams. We don't have to measure that out. We just want to make sure we're not using a lot. Okay, so in this case, I'm using roughly 30 milligrams, and I'm going to dispense all 3 right away. Again, no volatility, no risk of this reacting. I can dispense all of my solid samples at once before having to continue on to the rest of the procedure. So if we look the top of that test tube, so our extreme right started with ascorbic acid, and I just missed what that next one was, maybe the nicotinic acid, I believe. And then we move to our thiamine hydrochloride. Hopefully we can get it in focus there. And then the last one, which is actually facing the camera as a set of 3, is our tocopherol, which I have no idea how to pronounce, but that's close enough. You'll note that we're now going to jump into the solubility test, and that has to do with tocopherol, which we will see in a little bit. So this is our big empty space of just testing these things out. I know that white solid is a little bit difficult to see at the bottom. Do the best you can for the observations. I do try to align that test tube into the black space so it hopefully stands out a little bit more. Okay? So keep your eye on it and do the best that you can. I know we're looking at a video. Meow. And now the fun one, tocopherol. Tocopherol is a kind of honey viscous mixture, which means we can't really measure out 30 milligrams well. So what I'm struggling with off camera is dipping a spatula into the tocopherol and picking up some of that honey mixture and now putting that in the test tube. Okay? Now we'll add in our water so that we can observe and try and get that to dissolve. And that's what we're looking for here. It's not the easiest to work with, but hopefully you can at least get some idea of its solubility in this kind of weird honey-like mixture. And so after attempting to mix here, I'm going to pull the spatula out and show you the spatula so that you can try and see on the spatula if there's anything present that didn't actually dissolve and mix well. I am wiping it off in between to make sure we don't get any cross-contamination. I don't know why I didn't show that, because that would have been a useful technique to show, which is really just wiping it off on a Kim wipe. Same process, dipping it in, picking some stuff up, and then putting it into the test tube as cleanly as I can so I don't get stuff stuck to the edges. And we'll start by adding our ethanol. This next part's going to go kind of fast, but we'll get an aerial view of each of our solutions with some labeling to help kind of identify it. So what you should be doing is looking down those. We've got the white or the black background to help kind of show that. So you can see if there's white powder down there. And then for the tocopherol, these are impossible to friggin' see, but it's at least another observation. Now what we'll do is go through and heat each of those samples if they did not dissolve. We want to see if heat's going to help improve solubility. So all we end up doing is taking those test tubes. I'm trying to be very careful with the orientation and not switch it up so that the test tubes align the same. And we want to see if we get any observation changes. Time is definitely, sped up on these to help with that visualization or to shorten the amount of time that we spend in this. So again, little slight mix-ups, and you can kind of see if there's any white powder remaining after we do it. So now what we're doing is moving into the next one. Nicotinic acid, we've got our ethanol and hexanes, and you can see that kind of white powder when I kick it up. If you didn't catch it already, it might not be a bad idea to click pause on some of those just to make sure you get a legitimate observation or an easier observation, I guess I should say. Same deal, sped up time, a little bit of heat, see if we see any changes. In our last one, the tocopherol, you can make some observations to start, and we'll go ahead and run the heating, the same kind of quiet. It just looks like the video is paused. Good thing I had it in focus. But we are about to end the video, So when those come out, you've got your last observation and we're done with the experiment. So what I would recommend you do is take careful notes, maybe double back through if you think something has changed. Another thing that the observant person might note is that we're only heating ones that didn't entirely dissolve. That could be a good indicator for the substances that I, as the experimenter, decided did not dissolve. With that, I'd like to thank you for spending this last painful half hour with me, and good luck.